Let us now discuss about operations on process. So as the operating system is all about processes, so there are a lot of operations that are going on processes, right? So let us discuss about those. The first one is the process creation. So in operating system, actually the processes are created in somewhere, right? So in every process in the operating system is identified by a unique identifier number or unique ID that is called process identifier, and a process may create new processes. Processes will create more and more child processes. So here's an example. So this is a process P1 which PID is 1, and it can create multiple child of its own. So here we have seen that we can see that the P1 has created 3 child. Those are P2, P3 and P4, and they have unique identifier, unique PID. So, and these child processes may also create other child processes. So in this way, all the processes in the operating system actually form a tree, and this tree is called the process tree in the operating system. And whenever a process is creating a child process, so child process will also need some resources, the resources of the computer system, right? So from where actually this child process gets the resources? There's two ways. One way is the child process can get the resources from the operating system directly, or the child process can get the resources from the parent. The parent itself has some resources of the operating system. Some resources of the operating system is assigned to this process, right? And those resources what are possessed by this process, the child process can get resources from this section or this group of resources as well. So there's two ways. One is the child process can get the resources from operating system directly, and another one is the child process can get the resources from the parent's resources. Okay, so most of the cases actually child resources are bound to get the resources of its parent, not the operating system. Why? Because if we allow the child to use the resources from the operating system directly, then in the system any process may create a huge number of childs, because this process doesn't need to give resources to its child, right? The child will get the resources from the operating system, so he doesn't needs to bother about it. But if this process needs to give its resources to the child, then this process will think before creating any child. So that is why actually in the most of the operating systems the child process actually are bound to get the resources of its parent rather than the operating system directly. And parent process may pass initializing data to child process. Whenever this process is creating a child process, it passes some information, initializing information, some information that is required to start this process. It may pass those data to the child. So in this way actually processes are created in the operating system. So when a process is created in the operating system, there can be two scenarios. The parent continues to execute concurrently with its children. This can be one scenario. Or the parent waits until some or all of its children have terminated. Okay, so there's two scenarios. First one is the parent may execute in parallel with the child, and in another scenario the parent will pause its execution and will wait until the child has terminated. So in different operating system, different scenarios are followed, and each of these scenario has its own advantages and disadvantages. And in terms of address space possibility, there are two possibilities. The first one is that the child process can be the duplicate of the parent process. I mean, the child process will be the exactly same program of the parent, or the child process may be a new program that is different from the parent. So still same, the different scenarios is followed in different operating system. For example, in Unix operating system, fork system call will actually create a child process which is a duplicate of the parent process. So if we create processes in the operating system, and there may be different scenarios like this. So if we take the example of the Unix, how processes are created in Unix, so there are some system calls related to the process creation in Unix. So fork is a system call which actually creates a new process, and the new process actually the child process, which is actually the copy of the parent one. Exec is a system call that runs an executable file. Actually, exec replaces the previous executable file in the processor or in the CPU. And wait is another function that actually suspends execution of the current process. I mean, this system call pauses the current execution until one of its children terminates. Okay, so if we think about the Unix system, say this is a parent process has called the fork system call, so a new child process will be created. So when the new child process will be created, see, the child and the parent both actually are executing, and at some point the child is executing exec. That means the child is replacing the previous executable. Previously executing was the parent process, and child will replace that in the CPU and will be executed. And after some time, when the child is executed, it will call the exit function system call, which will actually terminate the child. So here actually the parent calls an wait. I mean, the parent is pausing its execution and is waiting for its child to be finished or to be terminated. So when the child actually calls the exit system call, I mean it terminates, then the child process then the parent process continues or resumes its execution. So in this way you can actually the new processes are created in Unix and are executed. So as I said earlier, whenever we call the fork system call in the operating system, the child actually becomes the same program as the parent. So how do you differentiate which one is the parent and which one is the child in Unix system? So whenever we call the fork function, and then the parent will return some value, the PID of the parent will be a positive value that is greater than 0, and the PID of the child will be 0. So this PID will be returned whenever we call the fork function. So by checking the values of these PIDs, anyone can say, or the operating system can understand which one is the parent process and which one is the child process. Now let us think about the process termination. So after some times we know the process will be terminated, right? So when the process terminated, it executes its last statement. I mean, how do operating system will understand that the process is terminated? When the process executes the last statement, or the termination may be caused by another process. I mean, another process is forcefully terminating some other process. So in these two ways actually processes are terminated in operating system, or operating system can understand that a process is terminated. So when the process is terminated, then the resources are deallocated. I mean, in the execution time, or while the process is in execution, the process obviously holds some resources of the computer system, right? So when the process is terminated, so it is very obvious that the resources that was held by the process, that will be free and that will be deallocated. So, and let us now think about the parent process. When actually the parent process terminates, a parent may terminate its child. I mean, we are talking about how a process forcefully or generally normally terminates its child. The one scenario is if the child has exceeded the uses of resources. I mean, the child actually gets the resources from the parent, right? And with the time, or with the flow of execution, the child is grabbing or is holding more and more resources, and at one point the child has exceeded the uses of resources that was allocated to him. So in this case, the parent forcefully terminates the child. Or another scenario is the task assigned to the child is no longer needed by the parent, so the parent may terminate the child. Or the parent is exiting, I mean, the parent is terminating. So if the parent is terminating, the child should also terminate, because the child actually gets the resources from the parents, and when the parent terminates, the parent deallocates its resources. So whenever the parent is terminating, it may terminate its child as well, and this termination is called cascading termination. Why cascade? This scenario is called cascading, that if the parent is terminating, then the child will also be terminated. They are related. So this is called cascading termination. So there's special kind of process in the system, or in the Unix system, that is called the zombie process. So when does a process, I mean a child process, becomes a zombie process? So if we see the scenario that a process has created, has called the system call fork and created a new child process. The child process has called the exec function and it is executing. Okay. So see, the child process has called the exit system call. I mean, the child process is done its execution, right? But the parent process, see, the parent process still has not called the wait function. So if the parent process doesn't call the system call wait, the parent process still then, if the parent process doesn't call the wait system call, then it will not be able to understand, or it will not be able to know that child process has completed its execution. So in this time, when the parent has not called the wait function yet and child has already executed, child has finished its execution, then in that time the child process is called zombie process. Why? Because the parent process still has not called the wait function, and the child is the information in the, what can we say, in the process table says that there is a child process is still executing, but the child is not executing. So it feels like that this is a zombie process in the operating system. I mean, there is no existence of this process, but in the entry in the process table there is an entry for this process. So that is why this process, this child process in that time is called zombie process. And when the parent process calls the wait function, then zombie process actually vanishes from the system. Okay, so for this period of time, this process will be called as zombie process.